Greetings. Welcome to this episode of the Harnessing AI series. I'm Peter Denning, your host and moderator. You have heard about generative AI. You've heard about how it works and all the kinds of promising looking things it can do, and also some worries about what it might do that people won't like. Well, in this episode here, we've got Professor Rodrigo Nieto-Gomez, who's going to talk to you about applications of this technology, which are very promising in some very fascinating areas. Homeland defense, first responders, wargaming, and other things where people are actually using this and putting it to the test. So Professor Gomez is a research professor in the NSA department, National Security Affairs Department. He's been involved with the Center for Homeland Security. He does a lot of work with applications of different kinds of technology in the internet, where they produce innovations and where they might not produce innovations. So he has a lot of experience, and he's going to tell you some very interesting things about what he's learned with his students about this technology. So, Professor?
Thank you so much, Peter.
Okay. Thank you.
Thank you. A few years ago, Steve Jobs famously said that computers were like bicycles for the mind. What he meant by that was that humans might not be stronger than a bear or faster than a cheetah, but we build tools, and with those tools, with a bicycle, for example, we become the fastest animal on Earth just using the physical strength of the human body. Computers were like bicycles of the mind because they multiply our capacity. They're tools for our intellect, not our muscles. Large language models are a new generation of these bicycles for the mind. And they are creating opportunities that we will need to learn to harness, both at the individual but also at the organizational level. So I want to talk a little bit about it today. Take us to the realm of innovation and entrepreneurship and see how these technologies are already revolutionizing the way we consider certain technological applications. Let's start very briefly with what is an LLM, and in this series there are much better episodes probably to define at the mathematical, statistical, and computer science level what they are. But it is important to remember that these are mathematical models that predict the sequence of an output based on the training and the calculation that exists. Emily Bender already cited on other episodes of this series, was mentioned before. It's capable of producing content that doesn't necessarily have a previous understanding or a meaning. So a way to understand it that is non-computer based would be to consider something like this little song, this rhythm, twinkle, little. If you said twinkle, 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 little star, well, you did this, you anticipated, you predicted what would be the best answer to the question given to you based on your statistical knowledge. Now, it could have been twinkle, twinkle, little hot dog, for all we care, because we don't know what it was. But based on the probabilistic experience that you have, where 100% of the expressions given to you were the result was twinkle, twinkle, little star, you've learned to respond to that input with that output. So this is something that is important to understand as we think about large language models, because it tells us what they can or what they cannot do, the things that they are afforded to us through the application of LLMs, and ultimately some of the ethical considerations associated to these stochastic parrots, to this capacity to calculate responses that sound proper and correct, but not necessarily understand a larger meaning, right? So these are the limitations of the AI. So we're talking about tools. We talked about bicycles for the mind. We are the tools we use, right? We as humanity, with an opposed thumb and intellect, have been able to build tools to shape our world around us. And right now, large language models are a very important tool that will and is already shaping humanity's environment in very meaningful ways. In entrepreneurship, we say that people don't want drills, they want holes. What we mean by that is that in general, a tool is important not so much for the technology the tool itself presents, that's important for the technology developers, but for the things, the pain points that it addresses among human desires. So you have a pain point, I need a hole because I need to hang a poster. Well, the painkiller for that pain point, it's a drill, right? But it might be something else. So we're trying to understand what are the holes that this new drill produces. And the interesting thing about this dance, something that Clayton Christensen famously identified in the idea of the jobs that need to be done, it is that the job of the entrepreneur is actually to take tools in ways that have not been anticipated by the technology designer and produce painkillers, produce services and products that nobody else thought about before, using the same capabilities that we saw before. And a good way of understanding this is to take the technology apart by what the affordances are built and understand what it is. It's important also to understand that this debate around LLMs that started in November 2022 immediately went into two places that I think actually are very poor applications associated to large language models, right? Immediately people started to think, well, is this a search engine? Is this a knowledge base? And we'll talk about that a little bit later, where I can go and ask it facts and it will respond to me, right? Is Google dead, right? And it turns out that the answer is no, right? That because of the way these models operate and the hallucination problem, there are no search engines. Now they can be combined with a search engine, and this is something that we're starting to see more, and that goes to the other elements of this technology, but they are not a search engine. Their data might sound plausible, and it might be completely wrong. They have a capacity to connect ideas in a way that is not only grammatically correct, but statistically convincing, because that is the way these models were trained. It's not factual. The data might or might not be correct. That's why it's so important to understand that as of today, given the current state of language models, the hallucination problem, it's part of the ways we should consider the limitations, the performance envelope of the technology. The good news is that the hallucination problem is also one of the best things that these models can do in other applications, in which that opportunity gives them features that are desirable. So they're not a search engine. They can be paired with one, as we discussed. And they're not a fire and forget, please go and write my essay based on the instructions of the professor, right? We know now that the results that come out of ChatGPT without proper guidance and, as we'll see a little bit later, without the importance of iteration, are fairly limited in their quality for multiple reasons, including the fact that these are models that are statistically appropriate, trained to the mean. And therefore, the result that you get, it's a result that will be in that mean, deprived from a lot of the advantages that would come from a highly creative exercise in writing. Now, that changes the moment you embed the human with the model, and in that regard, that actually might shift the equation to make these great tools of creativity. So what for? If they're not a search engine and you cannot just ask them to write your graduate level essay on the future of computer science, then what can you do with it? Well, you can do with it many things, right? But to understand what do we get to do with a product, oftentimes it's important to understand it by its components, right? At its core, a product like an iPad or an iPhone are a bundle of sensors, inputs and outputs, that are all put together in a certain way with some logic components, a CPU, a memory, a GPU, but ultimately they're nothing, right? They're literally a blank slate, a blank screen. Well, now right now it has my timer. Now it's a timer because some coder decided to program a countdown that is presented with a graphic interface that tells me how many extra minutes I have available for this talk. So ultimately, the parts of the tool give you the vectors of innovation that entrepreneurs will take in order to achieve some kind of advantage with this new product doing things that couldn't be done before. I personally have identified 3 elements, the same way that you would say that an iPhone has accelerators and pedometers and gyros and a screen and a haptic engine. Well, I would say that large language models, as we understand the products that today we associate with Anthropic or OpenAI or Microsoft Wingman, these are systems that when you put them on its parts to try to understand what are the affordances, the verticals, you get at least 3 elements that are composing this product. One is, and these things are an interface, right? And this is very important. These are an interface on natural language. Now, natural language interfaces are not new. We've been trying to get them right for a while. Siri, OK Google, Alexa, all of them are examples of different implementation of assistants using. What is different is that now they work. They work really well. And this interface is important because with the exception of human touch that we limit to the most cherished members of our family, 90% of our human interactions are based on language, natural language, right? We talk to people, right? The way we interact with the rest of humanity is we talk to people or we write to people. This is the way we exchange information. And we reached the point in which I can have more or less the same type of interaction that I have with any human being, with any of you who kindly are listening to us. I can have it with a computer. And this is radical. Right? So this interface component is really important, as we will see with a lot of the things, a lot of the products that are being put together using large language models. You get now to interact in a computer with a computer like if it were a human being in the same mechanism, language that you use. In that regard, this would be similar to, if you think an interface, a mouse, a computer graphic interface, or a screen. An interface has an input and an output. I provide something, and something is provided to me in the shape of vibration or pings by your phone or some display in your screen. So we have now a new layer of a perfected interface for natural language, right? And that's radical. The second one that I would call is a language calculating engine. And again, these models don't have calculation capabilities. In fact, a lot of the most interesting applications is when you put them together with other products like Wolf and Alpha to perform calculations. But what they do is they do the same thing that you and I do when we think out loud. And you start talking to yourself, and you say, OK, I need to go and buy some groceries, and I need lettuce, and we're having friends later, so I'm going to have some, and we're going to grill, so what do I need? And you're talking to you, and the talking in itself is part of your thinking process. Well, when these languages, when these large language models are putting together a string of grammatically coherent vocabulary based on your input, they are producing a kind of reasoning, and that reasoning gets captured in that process, right? Which means you can ask them things logically, and they will come with an answer, right? If you want to ask Alexa, what time is it? You have to use one of the 150 sentence permutations that the coders at Amazon decided is the way humans ask for what time is it. But to a large language model, you can come with the most exotic sentence, and the large language model will try to process it and come up with an appropriate answer. That is the large, this calculation, this transformation, this calculator for language, that it's the other part. And the third one is the knowledge base. And the knowledge base is almost a byproduct of the need of training these products in order for them to do their job. But this is where they get the most criticized, right? So they've been trained with a lot of the internet, frankly, the almost totality of the publicly available internet. So this is why you can ask them things and they'll answer with, most of the time, factual information that is more or less correct, as long as the question is not too complicated. So there is a knowledge base based on it. They know when World War II ended, and they know who is the current president of the United States. So there's knowledge baked into it. But this knowledge, as we said before, because of the hallucination problem, is actually not one that should be relied on just directly. It's a great starter point, and some answers will be fantastic, and some of those will be gibberish, right? So these are three components, right, that people are taking as the same way the creator of an application decides to use the touchscreen or the haptic engine in order to create Angry Birds. Well, as an innovator, I see these components, and now my challenge is, what can I do with these elements that I couldn't do before? This is what Brian Arthur, philosopher of technology, calls combinatorial evolution of technology. Every single new technology that gets to be created becomes a Lego piece that I can now use and mount on a different technology and recombine it to create yet another new technology based on this, right? So we've seen in another episodes of this series how, for example, the Department of Defense is taking some AI technology to use it as a co-pilot within the U-2 bomber, right? Well, that's combining an old technology from 1955, like the U-2, with a new technology, like the development of a large language model or some kind of AI, in order to create yet another affordance that is possible based on it. This is recombinatorial evolution in technology. It's really important because AI applications are ingredients in most cases. We shouldn't be thinking about AI as a standalone product. It's mostly an ingredient. It's like salt or like curry that you would go and add to something else, to do something else new with that. There is an emerging typology, and this typology might change and will change as things evolve, right? And this list that you have here, this is the typology that comes from the custom GPT shop, and we'll talk a little bit about what that is, from OpenAI, right? So the custom GPT shop is now the marketplace that OpenAI, and for those watching this video in the future, you let us know if that happened or not, but OpenAI is trying to make for AI applications what the App Store did for apps on iOS products. So a place where creators can go, put together a custom GPT that performs a specific task, and then go out and try to sell it to the public. So these are the categories based on what people are doing that the company OpenAI, that today is the leading company in consumer-facing applications of large language models, has come up with. And they already have changed this categorization, at least ones that I am aware of. So that tells you that they are learning themselves what is the best way of organizing this market. You will see that at the left we have DALL-E. DALL-E is their generative image application. And there's a lot of custom GPTs based on using generative images, not language. So this is one, and we'll talk more about that. Writing. A lot of the stuff that people are doing with GPTs today is based on writing stuff, helping you to write specific kind of content, etc. productivity, and this is not surprising. This is a lot of applications that would be used in office setting environments to try to automate tasks that today are done manually. Research and analysis, programming, education, lifestyle, you understand. I want to drill deeper in 2 or 3 of these categories just to give you an example. As of February 2024, what are the main uses by adoption within this shop? But I do want to warn you, this is a temporary typology because things are changing. As I was putting this talk together yesterday, OpenAI announced Sora, and Sora is their video-based application, so you will probably in a few years be familiar with it. But as of today, in February 2024, the image that you're watching right now, the video that you're watching, have all been AI generated based on the prompt that you see at the bottom. So the prompt is instruction that gives, through natural language, in this case the English language, the instruction to the LLM, in this case to Sora, to then go and create the graphic images that you have. This didn't exist yesterday, but it exists now, right? So the amount of products and capabilities that are coming to market right now, the speed in which we've seen these applications come has been dramatic. So what is true in 2024 for these categories might not be true tomorrow. But that's why it's so important to understand the verticals of what this technology can do. Because if the applications are different, this is still an interface. Again, it's human interface, me being able to tell the computer what I want. It's still a calculation engine, and there's still a knowledge base, even when you're talking about something like AI-generated video. So for writing, right, you will see things like an academic assistant, an all-around writer, right, and a slide deck creator. So those are examples, very evident, right? What would you want from AI if you could? Well, those are some examples. DARPA right now, there's a great DARPA competition in which people are exploring how large language models could be used to customize education, specifically to individuals, to warfighters, so you could really transform training. Any of us who has gone through any of your training requirements yesterday or the day before that you looked at what we've done, you know the quality of them. I will let it, so there's an opportunity to revolutionize that. Interestingly enough, I just wanted to mention the number 2 that is called Humanizer Pro. And Humanizer Pro is part of the cat and mouse game that we're playing right now, in which people develop tools to identify AI-generated content. A lot of professors that are very opposed to the use of generative AI, so they run to see, well, Humanizer Pro studies the models used by these AI detection tools and transform your text so those tools will consider it to be human-generated, creating this cat and mouse game that has been now identifying content from humans versus AI. Research, right? So, and this is very relevant to the stuff we do here at the Naval Postgraduate School. Consensus that looks at different 200 million academic papers to try to come up with an answer that is scientifically sound. There are some other applications like Wolfram that will connect you to the mathematical engines so the results are more appropriate. So you can see how there's an effort again to use them as an interface, right? In this case, for example, the case of Wolfram, you would ask a question in natural language, and then the computer would go through an API to connect to an external service. So you're replacing the use of the mouse, for example, of the computer, or you having to code the appropriate equation or code the Python search code by yourself. Lifestyle is fun, so I get Kayak, a travel agency. Well, that's an interface. I want to go to Bora Bora or Cancun. I want to go on January 7th, and I want to fly economy premium. It'll go and look for you through the APIs of these different companies, the right elements, put them together, and give it to you. So again, even though we don't know what the next high-profile innovation is going to be, we know that it's either going to be an interface, some part of this processing capability for language, or taking advantage of the knowledge base of the model. We have organizers, classifiers, agents, provocateurs, simulators, assistants, interface, etc., etc., etc. That list of etc. is going to keep growing. A lot of money in VC right now, it's going to the so-called provocateurs. A lot of money is going to the assistants. Assistants are interesting. I did want to mention something about them because this is one thing in which these models are going to, again, revolutionize the way we interact with computer-generated content. So far, these are calculators, right? You throw at them something, and they make a calculation, and they throw it back at you, and that's it. That's the end of the interaction. You give an input. Even for the video one, I need an image of a dog jumping houses in the middle of Murano, Italy, and he'll crunch the numbers and give you the data. An assistant is different. Assistant might run in the background, right, and keep doing things even when you're not asking them things. And it might exist and have some kind of permanence, so even though you're not using it, or you use it today and tomorrow, they will remember the past interactions. Now, this from a computational perspective is difficult. The more the data that they have to know from you, the more intensive the computation becomes. In this regard, this flips the equation of a lot of Moore's law-like dynamics, that the more you do something, the cheaper it becomes. Here we're actually at the opposite level right now with the way the models work. But assistants are one of these places where you could imagine a little bit like Jarvis from Iron Man, the desire for having a technological capability that will know you and know exactly where you've been in your interactions with it. I wanted to show you some custom GPTs, if I show you first from the ChatGPT store, that have been experimented with here at CHDS. None of them have been released in the wild, but they've been part of our learning at the Center for Homeland Defense Security, where we have the privilege of having hundreds of first responders, emergency managers, law enforcement, fire departments here, playing with this technology, seeing how we could make government services more efficient and accessible through the use of large language models. So what you have here, and I won't go through all of it, is using not even a custom GPT, but this came from before, when you started to be able to provide what is called custom instructions to ChatGPT. And this prompt would help you navigate the intricacies of the National Flood Insurance Program, which is a very complex piece of guidances and legislations. The prompt not only had the GPT not only had the prompt, but you would also upload the proper documents cited here, and we saw the answers. The answers were really good, and they were capable of guiding a layman on questions that they might have associated to the specific piece of complex federal policy. Let me show you one that I found very interesting. It's a grant navigator, right? So how to apply for grants. And we're seeing a lot of these, and the results are very positive. Grant applications using GPT in place where are being granted. Money is being allocated to people who use them in order to put their grant applications together. But this one I want to show you as a genesis, right? I asked some students to please keep a journal of how they were developing these tools, so we could see how they were growing. And you can see at the beginning here, this is the first prompt, right? And you can see how short it was. And this is what a lot of people were doing. This is what I said about don't ask it just to write your paper, right? And we analyzed it and we compared the results, and they were okay, and there were some limitations, and there was so the second generation of this prompt starts to provide more information that were required, and it starts to grow on the tone and starts to say not only who am I, but who you are supposed to be. This comes from an iterative process, and this is something that will be part of my conclusion, right? Working with LLMs is a lot like debugging, and it requires constant iterations. By generation 3, you can see how much more complex the prompt has gotten. I'm not going to read it all, but you can see there how many small details had to be coded into the system so the prompt would provide the answers that were needed. The results were fantastic by people who had been part of the grant administration process. They saw that result as very, very positive. So this is a skill. We call it prompt engineering. right? I'm not a big fan of the term because prompt engineering assumes that there is a field of engineering exclusive only to those who are experts in that field. I like to talk about prompt literacy or prompt design, right? And the same way we had to learn as humanity's complexity increased and most people were forced to need to learn basic math and to read and write, I think that the need of literacy, of prompt literacy, is going to be such that every single human on the planet in the next few years will have to have a sophisticated, complex adaptation to learn how to prompt engineer or prompt design effectively. The reason is very simple, because if you don't do it and your competitor is, you have lost a core competitive advantage. So how do we get there? What are some core principles for engaging this code? How do you talk to code? How do you learn to talk with stochastic parrots? Here are a few rules. By no means they are the list is not exhaustive, but it's certainly one that I hope will leave you an actionable series of ideas to take with you as you start to interact with these technologies. Where to use them? Well, Voltaire very famously said that you should not let the perfect be the enemy of the good enough, right? So this is one place where you have to be very aware of that. LLMs are exist today in the realm of the good enough, right? They make mistakes, they hallucinate, they come off by a 2%, they fail in ways that humans might not fail. Their failure systems are different. So LLMs exist or should exist in environments where good enough is good enough. What I'm saying with this is that if you're operating in a high reliability environment, you probably shouldn't be releasing an LLM into a large language model into the wild at this point. Don't connect them to the nuclear reactor. Don't give it the nuclear codes. Don't let it operate the floodgates. These are not tools that should be using high reliability systems. Now, they can be used as part of a fallback system or as a part of a redundant system, right? But they are not today tools that should be used where high reliability is essential, right? There are other ways in which you can build high reliability on top of them and where you can be used in order to increase reliability of other systems, but LLMs today are technologies where good enough is good enough. The good news is that most applications in humanity are like that. We don't deploy perfect technologies. In fact, for those in the technology development cycle, right, Lean or Scrum, it's precisely a process of constantly evolving and improving technologies because we know they're imperfect. But this is very important, especially in our job, in the Department of Defense. We want to make very sure that we understand that these technologies are good enough. They're not perfect, they come with flaws, and if high reliability is important in your application, then LLMs should be limited in their use, at least until other fallback or redundant systems can be put around them. Interacting with LLMs changes your role in the creation and application of applications, right? So Christopher Nolan recently in the news, lots of Oscar nominations. We know when you are watching a Christopher Nolan movie, right? So you go and there's something about a Christopher Nolan or a Steven Spielberg movie that feels like there. But here's the deal, they are not the actors. They don't direct, many cases, sometimes they are producers. The Christopher Nolan doesn't write the script, there's a script writer. They don't choose the story directly, they have scouts that are out there also looking for good stories. So ultimately the role of a producer or a conductor is to coordinate many other creative efforts in order to achieve an outcome, right? When you're working with a LLM, you now have a staff, you now have a team, you have a bunch of droids because they can do a lot of things that you couldn't do before, that you are going to be guiding, that you're going to be taking them in a certain direction for them to perform a certain task. You remain as human today the conductor, and being able to transition from this idea where you are trying to perform every exact duty to a place in which what you will be doing is performing the direction of the system is really important. Aviators go a little bit through this process with automation precisely when they go from flying small trainer airplanes and Cessnas, small Pipers, into getting into more complex airframes where they go from flying by the seat of their pants, by feeling every single aspect, into becoming the managers and the supervisor of all the automation systems that our aircraft has. We're starting to see that in places where we were not used to, like clerical functions, administrative functions, in which now every single individual, each of us, have now the staffs that before only really wealthy people had, right? You have a ghostwriter, you have somebody who can keep your agenda, you can, all of those funky things that we associate with the tapestry of power in the office space. Well, today LLMs can perform a lot of those duties, but you need to know what you're doing with it. How do we prepare an organization to the post-generative AI world, which is where we are right now? Well, if you think about it, today we have categories, right? So the Department of Defense does some of these in different ways, but it's more or less the same. In the private sector, you will have a chief technology officer that buys toys for people and builds the new tech and deploys the new tech and manages the adoption. You have HR, right? So you have the chief human resources officer whose job is to deal with humans. And then in some organizations, not all, you will have something like a chief process or innovation officer of who manages all of the logic flows within the organization. Well, it turns out that now there's a serious question if we should be thinking about a new position where would be the chief artificial intelligence officer or something like that, because it's not HR, because it's not a human, but it acts like a human and performs human tasks, right? I saw the other day a GPT that can take my order in Starbucks or McDonald's. It's a technology, but it's a technology that transcends to processes and hiring practice, etc. So it's almost like we have this new category of assets that we need to think about it. And many organizations are thinking that more than the specific applications that they go and buy into the market, what they need is to become AI friendly, to build institutional capacity, to adopt technologies constantly, test models, test places in which that can be done, in the same way that we have a capability to manage human resources, or we have a capability to buy and test new technologies. For you personally, right? That was for the organization. For how do you prepare yourself for the post-generative AI world? Well, one part is that we need to start thinking about how computer coders think, and a lot of the applications and efforts will require to develop a debugging mentality. And debugging mentalities are weird because we, in social sciences, for example, we're not used to having a different product than the product that gets rendered, right? So when I'm writing a social science paper, what you see is what you get. What I'm doing in the computer is my product. Whereas if I'm coding on Swift, I have the code on one side, but then I have to compile and see the result of the app at the other side. Today, you have marvelous interfaces like this one that allow you to be coding and compiling in real time. Well, working with LLMs, even with language, it's like that. You build a code, it doesn't come well, you go back, you tweak it. I showed you 3 generations before. This mentality of building something, you test it, you write, is very different to how humans have been writing in natural language for many years. But I think it's going to be very important, and that requires experimentation. You have to sit with this thing, work with something, change it, get the output, look at it, see where's wrong, tweak it, get back, do it again, rinse and repeat. And I've done this. It can be addictive. It's very easy to lose yourself and spend 8 hours just bouncing a prompt back and forth. The same experience that computer coders manifest sometimes, where they're really zeroing in a problematic part of the code. But this is not how we humans historically have interacted with natural language. And this is a very different dynamic. Prompt engineering will require us to get into this debugging mentality more easily. We think based on the tools we have. This is something that I never thought about until I read this quote before. But the tools we have afford us the ways in which we end up thinking. And the tools that we have right now, like ChatGPT, are transforming our ways of seeing the world. For digital natives, the 5 or 6-year-olds, my 4-year-old daughter, I coded a GPT assistant for her based on her interest, and today she will plug it and start asking questions that are based on the learning objectives that I have. Of course, I always pay attention and I want to know, and I can read the transcript of what the conversation was, but it is dramatic, right? Remember how we used to say how interesting it was to see kids now playing with touchscreens and that stuff? Well, this is exactly what tools do to us. They change the way we see the world. Large language models have changed the world already, but what they've done is nothing compared to what they will do as they get developed. Our challenge here is going to be to learn how to effectively engage with these technologies as we move forward. For the Department of Defense, because we are in a competitive space, we don't have the privilege of ignoring a technology, because our near-peer competitors are hard working into improving their warfighting capabilities based on them. So with all the respect that we have for bicycles, that we know that they make us faster, but we also have to wear a helmet, right? With LLMs, we need to understand how they make us stronger and how they improve our capacity to do things, while at the same time knowing what safety measures we have to put in place so we don't break our head in the process of using it. So thank you so much. My contact information is on the QR code, and please do not hesitate to reach with any questions or comments. I'm always excited to learn from you guys. So.